Welcome back, guys. Today we're going to look at the function. So we have a function up here, the function f of x. And I want to look at its behavior at these particular points, a, b, e, f, and g. Now, because it's a graph, and it's not a good graph, I'd label them that b is the minimum, e is a POI, a point of inflection, and f is a maximum. Now understand, f is what we call a local maximum, because in this area, if you're just looking in this small little area, f is the high point. Yes, if you zoom out overall, there's no absolute max. I'll keep that in mind. This is potentially an absolute min. I'd have to look at this point to determine that. So looking at my graph, I want to talk about a few things. First of all, I'd love to look at this and go, where is the function positive? At what points is the function positive? You gotta understand what it means to be a function is positive. There's certain things, you just got the flashcards, you just gotta get into your head. A function is positive when the graph is above the x-axis, all right? So we look at this, the points that are above the x-axis, and I'm sorry I put one really close, but A is above the axis, okay? A and F are points above the axis. And so that's why I'm saying the function is positive at A and F. Points B, E, and G are below the axis. That means they have negative y values. So these are negative y values, these are positive y values. You remember the function are the y values. Okay, let's move on to the second component, the derivative. Where is the derivative negative? So I'm throwing at you some questions to see if you can pay attention. The derivative is negative. That's what this says. Derivative is negative. We got to know what that means. Well, the derivative, flashcard. The derivative negative means the function is decreasing. That's what I keep in my head. F is decreasing. So I'm looking for at what points does it look like the function is decreasing, going downhill. Well, look at A. I would say we're on the decreasing part of the function. We're going downhill. Definitely A. Look at B. Well, B, we're not increasing or decreasing there. We're at a max or min. So if I was to do an extra question down here, where is the derivative 0? I would say that's at B because that's at a minimum. The derivative, again, is the slope there. The slope at B, if you imagine a little tangent line there, and might as well bring it out its partner. The tangent line at B and F are both horizontal. The slope of the tangent line is the slope of the curve there. And so what we have is that at B and F, we have the derivative that is the slope 0. That's why when we look for max and mins and we're doing the analysis, we take the derivative equal to 0 and we find them. So B and F are where the derivative is equal to 0. Notice, the derivative gives us some very valuable information, where you got the max, where you got the minimum, and it also tells us where the graph is decreasing. For example, at A, we're decreasing. The derivative is negative. Let's look at G. We're also decreasing through G. All right, if you draw the tangent line at G, I like to draw the tangent line at G, and the tangent line at A, both of those tangent lines have negative slopes, right? These are negative slopes. That's why I'm saying A and G, we are decreasing. To be complete in my lecture, looking at point E, we're actually going uphill there. We're actually increasing there. So at point E, I'm not writing it down, but at point E, I would say the derivative is positive. So derivative is negative when I'm decreasing. Derivative is positive when I'm increasing. Derivative is 0 at max and mins. And that's a nice complete breakdown of the derivative. Now, the second derivative. Well, the second derivative talks about the bends in the curve, the second derivative. If I wanted to know where the second derivative is positive, at what points over there is the second derivative positive, the points, I'm picking the points, I'd look at the bend. Second derivative is positive means concave up. Kind of run out of space. I can abbreviate it, C up, but it's concave up. Look at my previous videos for the idea of concavity. Concave up, C up. It's when you take a straight line and bend it up. When you start bending up, that's the concavity. So I'm looking for bending up. And to be honest, At A and B, I'm both bending up, because if I'm going to make B, I got to bend the wire up. From B to A, I'm bending the wire up. Also, at G, I'm bending the wire up. So A, B, and G, I am bending up. I'm concave up at A, B, and G. Just for completeness, at F, the second derivative is negative because I'm bending down, okay? At F, I'm bending down. Well, that makes sense. At a maximum, right? At a maximum, you got to bend down. If I'm going to maximize, I got to bend down, concave down. At a minimum, you got to concave up, bend up. So I knew right away, concave up, concave up, concave up, bending up. Right at F, we're bending down. The curve is actually bending down. So the second derivative at F would be negative. E is a very special point. E is actually where the second derivative is 0. E is the only point with that. If you look at E, that's why I labeled it, because visually finding a point of inflection, almost impossible. That's why you need the equation. Given the equation, finding the point of inflection can be done not too bad. Look at some of my other videos about point of diminishing return and point of inflections, and you'll see that. But right now, visually, if somebody labels the point of inflection, I know what they meant by that. So what is a point of inflection? It's where the second derivative is 0. Great, that's not helpful. What does it mean? It's a point where the concavity changes. Look at it. The bend. So if I'm bending this piece of wire, I bent up and then I bent down. It's the point where the bend goes from up, the concavity goes from up to down. A point of inflection is where the concavity changes. Now there's another one over here. I didn't say it was G. I didn't label G that. I don't know where it is. It's somewhere in here. There is another point of inflection. I agree. To go from down to concave up, there's got to be another point of inflection. So concave down to concave up, there's another one. Don't know where it is. That's why I didn't show it there. I like to highlight so there's no doubts when you're doing a visual scan what are max, mins, and points of inflections. How does one find them? Look at my graphing videos to see how I completely rip apart the function to find max, mins, and points of inflections. Thank you for watching this video, and I look forward to you watching others of mine.